This is question 10 from section 7.5, day 2. A couple questions over it, so I thought I'd do a quick video on it. So we're looking at tangent of 3 theta plus 1 equals secant of 3 theta. Now, the issue here is that the tangent and secant are both raised to the first power. So there's no substitutions or anything like that that we're aware of that can allow for this. So what we're going to do is actually square both sides. So I'm going to square the left-hand side and square the right-hand side. So when I do that, squaring the left-hand side, so it's going to give me tangent squared 3 theta plus then 2 tangent of 3 theta plus 1. And the right-hand side is going to be secant squared of 3 theta. And here's where we're going to make the substitution right there, is that if you remember, tangent squared theta plus 1 is equal to secant squared theta. So I'm going to plug that in instead. So it's going to give me tangent squared 3 theta plus 2 tangent of 3 theta plus 1 equals tangent squared 3 theta plus 1. And what happens here is a lot of nice things. The tangent squared cancels. The plus 1 cancels. So it leaves me 2 tangent of 3 theta is equal to 0. Divide both sides by 2. It leaves me tangent of 3 theta is equal to 0. So then we're going to ask ourselves, okay, well, when does 3 theta, we're going to solve for 3 theta, when does tangent equal 0? Okay, well, it's going to happen at 2 of these 4 points. Remember, tangent is sine divided by cosine. So here, it allows me for 0 divided by 1, so it gives me 0. And then here, 0 divided by negative 1 also gives me 0, so pi. So 0 and pi are my 2 solutions for 3 theta. So then the next thing we're going to do here is we're going to add our pi k, because remember that's the period for tangent is pi. So we'll do that to both these. All right, then we're going to divide everything by 3. So when I do that, I get theta is equal to 0 divided by 3 is just 0, and then pi over 3 times k. This one here is going to give me theta is equal to pi over 3 plus then pi over 3k. All right, so then remember what k is. K is our counting tool. It's got to be an integer. So let's just say, let me get rid of this picture real quick. Let's just say k is 0. That would give this to be pi over 3 times 0, which is just 0. Okay. So when k is 0, that gives me theta to be 0. Think about down here when k is equal to negative 1. Does that give me 0 as well? You get pi over 3 plus pi over 3 times negative 1. Those are canceled out, give me 0. So what I'm showing here, trying to demonstrate here, is that per whatever k is, these two things will eventually give the same answer. Okay? So I'm just going to start with this one. I'm going to just say pi over 3k is going to allow me to find pi over 3k is my formula for part A. That's going to allow me to find my then finite solutions. So we say find the solutions in the interval 0 to 2 pi here for part B. So this would be part A. Part B then says, okay, well, basically what you can do is you can let k equal 1, or actually let it be 0 first. K be 0, and that gives me theta to be 0. If k is 1, then it's going to give me theta is equal to pi over 3. If k is 2, that's going to give me So what, pi over 3 plus, times 2, which is then 2 pi over 3. There's another one, okay? Now, I'm going to keep going because this is between 0 and 2, or I guess it'd be this one. That's between 0 and 2 pi. That's between 0 and 2 pi. That's between 0 and 2 pi. So what if k is 3? Well, if k is 3, I'm back to pi over 3 times 3. Okay, so that's going to go pi. If k is 4, that's going to be pi over 3 times 4, which is 4 pi over 3. And if k is 5, you get 5 pi over 3. And if k is 6, we get 2 pi. I don't know what else. I was thinking about something else. So 2 pi. So those are solutions. Now, if you see here, and this is where I think some people are getting stuck, let's put boxes around all these options. You see in there, I'm going to give you 3 solutions. We just found 1, 2, 3, 4, 5, 6. Those are all between 0 and 2 pi. Why did we find more solutions than what our really solutions, or what really answers are? It's because of this step right here when we squared both sides. Okay, we brought in extraneous solutions. So what I'm going to do, and this is, I would strongly suggest this, just take your take Desmos or whatever calculator you're using, and just type in tangent of 3, I'm going to use t for theta, plus 1, and then secant of 3t for theta. So I'm typing in that way, and all I'm going to do here is just go through my t value. So t is 0, and we'll see, do they give me both the same response? So they do. So that's going to be a solution, so I highlight that one. Then I go pi over 3. And there you see, now when I get pi over 3, they're different. So not a solution. Then I'm going to try 2 pi over 3. Both give me 1, so we're good. So that's a solution. Try 4 pi over 3. Oh, I guess I didn't highlight this one. Pi. So we got to try pi. So one's pi, they're opposites, so that's not a solution. Get rid of that. 4 pi over 3 should work. Both 1 there. 5 pi over 3 does not work. They're 1 and negative 1. And then 6 pi over 3 or 2 pi, they work, okay? Now here's the thing. We got 0 to work, 2 pi over 3 to work, and 2 pi to work, and I guess 4 pi over 3 to work. We got those 4 to work, okay? But 2 pi is not part of our answer. Why is 2 pi not part of our answer? Look at that interval right there. Zoom in on that for you. You see it is a parenthesis, so you do not choose those.